Hello, welcome to the final video for assignment number 26. Good work so far. Keep up the hard work. We are going to finish off by, now that we've stopped at the black line, we're going to finish off by putting the bottle down right at that point, backing up and turning around 180 degrees and driving forward a little bit more. So maybe we need a comment to just remind ourselves of what this next section of code does. We'll say put down bottle, turn around, drive away, something like that. So we are going to start by putting down the bottle, right? That means we need some arm movements. By the way, maybe you noticed in your assignment document, let me take you over to the checklist. This is everything we're working on. You do get extra credit for putting the bottle down without knocking it over. So we might want to be extra gentle with our water bottle. Let's do that by setting our arm velocity to be pretty slow. We'll set it to like 25%. And then we will move our arm down the same number of degrees as it moved up earlier. So I set mine to 45. Maybe yours is different. But I'm going to go down 45 and see how I do with putting the bottle down there. So now once I move my arm down, I should be able to then open my claw and release the water bottle, right? So I can use my open claw method again. How handy is that? I don't have to rewrite it because I have a method. That's what methods are for. Now that we have put down our water bottle, we're going to back up. So let's use our drivetrain, right? How much are we going to back up? I think not too much. We're going to drive in reverse. No, let's try 100 millimeters. You can kind of play with that. Make sure you don't knock over your water bottle. Because once we back up, we're going to be turning around 180 degrees, which I think you know how to do because we did it right here. We're going to turn right. For 180 degrees. And then we're going to drive away the length of one tile. So it sounds like we're driving forward, and maybe you can go ahead and measure the tile, figure out how many millimeters it is, or you could do some guessing and checking in order to see how far your robot needs to drive. So I'll let you fill in that value on your own based on your testing and your measuring. So I think we have some good code here. Remember, hopefully you changed some of these values, right? Your job was to figure out the distance value. It was your job to figure out the reflectivity value. It's your job to think about how long you need to open and close your claw for. Oh my, I just noticed. I think over here when we're putting the bottle down, we probably should be opening the claw, not closing it. Oops. Maybe we'll close our claw in a minute. That is what we call a bug. Sorry about that. So now I think I will want to close my claw at the end though. I'm going to make that part of my project. But anyway, so you'll want to fill in your own values here for how much you're waiting when you're opening and closing the claw. So this is a good start for you guys. This is the code that will get you basically going, but I want you to then go ahead and understand what it's doing to the point that you can customize and make these values appropriate for the actions you want your robot to take. I hope that this has been helpful, and this is just meant to be another way for you to have the kind of lesson I'd like to do in class, but maybe at your own pace, and maybe with you stopping and pausing and testing when you need to. So I hope that it's helpful, and good luck with the project, and hopefully we'll have a good time in class.